Hi friends, welcome to all. In this video, we are going to configure IPv4 floating static route. In the previous video, we have seen how to configure IPv4 static route using exit interface. So you will get the link in the description below.
Before coming to the configuration, hey friends, your support means everything to us. Please like, share and support our channel. It really helps us grow. And don't forget to subscribe and click the bell icon so you will get a notification whenever we upload a new video. And if you ever need a technical support, feel free to contact our team. All the details are given in the description below. Thank you so much for being with us.
Coming back to our configuration. First of all, we will design the topology. We need a redundancy, so we will add 3 routers for 331 series. Then we will add 3 switches 2960 series. Okay, here I am going to add only 2 switches. Then some PCs. We will rename these devices. Consider this is R1, R2, S1, S2. So here I have PC1, PC2. And this is RTR. We will connect all these devices. So before that, we will connect routers using this serial. So let me add serial ports. We need to put off this device. Then here we can see this serial interface, then put it on. Same thing we can repeat on other routers. Coming to R2. Now, first we will connect these routers using serial. R1 serial 0/2/0 to RTR serial 0/2/0. Then from R2 serial 0/2/1 to serial 0/2/1. Then we will connect R1 and R2 serial 0/2/1 and on R2 serial 0/2/0. Now we will choose copper straight through, and from R1 gigabit Ethernet 0/0/1 to S1 G0/1. The same way on R2 G 0/0/1 to S2 G0/1. Also we will connect end devices. Here in this topology, we can see there are 5 networks. So just I will highlight those networks. So this is the first network. Then here we can see the second network. Then we can see this point-to-point connection. So let me give this is one network. This is another network. And we got one more between R1 and R2. Consider this is network 1. I will give N1. And here we will use the IP address 172.16.1.0/24, and this is N2 network 2, and here we will use 192.168.1.0/24, and also we have this router to router connection. Consider here N3. Here we will use 10.1.1. Okay, here I will give 10.1.1.0/30, and here we will use, this is network 4, 10.1.2.0/30, and this is N5 network 5. Here we will use 10.1.3.0/30. So here we can see all the 5 networks, and also we given its network address. Now we are going to label all the ports. So here I will give, this is G0/0/1, and here also G0/0/1. Then we have serial interfaces here, serial 0/2/0. Other side also we connected to serial 0/2/0. Then here between R2 and RTR, serial 0/2/1. Then on R2, serial 0/2/1. Then between R1 and R2, here it is serial 0/2/0, and here it is serial 0/2/1. Now it will be more easy for us to configure the device using these labels. Also, we will label the IP address we are going to give to each device. So here for this PC1, we will give 172.16.1.10. So I will give a .10 here. Then here in this PC2, we will give 192.168.1.10. Then for the default gateway, here we will give 172.16.1.1. Then here we will give 192.168.1.1. Then here between R1 and RTR, for this interface we will give .1, that is a 10.1.3.1. Other side we will give 3.2. Here we will give 10.1.1.1, and here also we will give on R2 serial 0/2/0 we will give 10.1.1.1, and here we will give 2. Here also we will give it 2. So we have all the information in our topology itself. So now we will assign IP address to each devices. So here, first of all, we will start from PC1, that is network 1. So we have a PC1, then we will configure this interface G0/0/1 on this router R1. First of all, let me set IP address on PC1. So we given 172.16.1.10. So 172.16.1.10. So subnet to mask we given /24 as prefix. So here I will change the subnet to mask. Then default gateway we need to configure on R1. So that is 172.16.1.1. Now we are going to configure this router R1 interface G0/0/1. So coming to R1 CLI, would you like to enter the initial configuration dialog? No. Enable configure terminal. In short, just I will set the host name as R1. Also we will give no IP domain lookup, and we are not going to do all the basic settings in all the devices, so that we can do it in the real world. We must configure everything perfectly. Now we are going to the interface G0/0/1, and we are going to set a description connected to S1. Okay, description also we are not going to set in this topology because we are focusing on floating static route. Let me set the IP address for this interface, which is very important. So it's 172.16.1.1, then to mask, and we need to activate this interface using no shutdown command. So we can see this interface changed state to up. Here our network N1 is ready now. Just we will test the connectivity between PC1 and R1. We will ping to default gateway, that is 172.16.1.1, and we get the replies. Also we can do the self ping from PC1 to PC1 itself, so that is 1.10, we get the replies. Next we are going to configure network 2, and here we planned 192.168.1.0/24 network. First of all, we will configure the IP address for this PC2. IP configuration address is 192.168.1.10. Submit to mask. Then default gateway, we need to configure it 192.168.1.1. The IP address of this interface G0/0/1 on this router R2. So we will configure that next. Coming to R2, no, enable configure terminal, and let me set the host name, and no IP domain lookup. Then we will go to interface G0/0/1, and we will set the IP address 192.168.1.1 with the subnet to mask. Then activate this interface by no shutdown command. Now here we can see the link between R2 and S2 is up. We configured this network 2. We will test the connectivity. Coming to PC2 command prompt, we will ping to the default gateway, that is 192.168.1.1, and we get the replies. Also just we will do the self ping 192.168.1.10, and we get the replies. Next we are going to configure this point-to-point connectivity between routers. So first of all, we will start from this RTR and R2. Here we can see this is network 3, and we given the address as 10.1.1.0/30. So first of all, we will configure on RTR interface serial 0/2/1. So device must be powered on. Okay, so let me put it on. So just I will click on fast forward. Then coming back to RTR, no, enable configure terminal. We will set the host name as RTR. IP domain lookup. Now we will go to interface serial 0/2/1. So we can see this interface, and here we will set the IP address at 10.1.1.1. IP address 10.1.1.1. Then to mask, we given prefix as /30. So it's a 252. Then activate the interface by no shutdown command. Then on the other side, on R2, that is serial 0/2/1, we will give the IP address at 10.1.1.2. We will go to that interface, that is serial 0/2/1, then set the IP address 10.1.1.2, then submit to mask. Activate this interface. Okay, no shutdown. We can see the link between RTR and R2 is activated. So our network 3 is configured with the IP addresses. Let me ping. We will test the connectivity between RTR and R2. And we will ping to 10.1.1.2. We ping to the other side. So we can see success rate is 100%. Also, we can ping to 10.1.1.1 also. Okay, it's working. Now we will configure network 4, that is 10.1.2.0/30. So we can see the interface. On R2, it is serial 0/2/0, and on R1, it is serial 0/2/1. First of all, we will configure on R2. We will go to interface serial 0/2/0, and we will set the IP address, that is a 10.1.2.1 with the submit to mask. Then activate the interface, no shutdown. Next, we will go to the other side, that is on R1. Enable configure terminal. We will go to the interface serial 0/2/1. So here we can see that. We will set the IP address, that is 10.1.2.2 with the submit to mask. Activate the interface, no shutdown, and immediately we can see the link between R1 and R2 is up. We will test the connectivity between R1 and R2 and ping 10.1.2.1. So we ping to R2 serial 0/2/0. So success rate is 100%. Now we'll configure, we will ping to R1 serial 0/2/1. Okay, it's work. Perfect. Now we will configure the link between R1 and RTR. We given the address 10.1.3.0/30 for this network 5. And also we can see on both sides we connected to the interface serial 0/2/0. First of all, we will go to R1. We will go to that interface, configure terminal. Then we will go to that interface serial 0/2/0. Then set the IP address. We planned 10.1.3.1. Then the submit to mask. Activate this interface. Then we will go to the other side on RTR, interface serial 0/2/0. Configure terminal. We will go to interface serial 0/2/0, and we will set the IP address 10.1.3.2. Then the submit to mask. Activate this interface. Okay, it is activated. Now we will test the connectivity. Ping 10.1. Yeah, ping 10.1.3.1. Perfect. Also we'll ping to 10.1.3.2. Perfect. So friends, we configured all the devices, all the interfaces with its respective IP address. Now, as like our previous video, we know that we cannot communicate from PC1 to PC2 because PC2 is a remote network for PC1. And this R1 is aware of three networks. R1 is aware of N1, N4 and N5. And this network is not aware of N3 and N2. The same way, R2 is aware of three networks, that is network 2, network 3 and network 4. And R2 is not aware of network 1 and network 5. They are remote network for this router R2. See, I just labeled those information. You can see R1 connected network, that is 172.16.1.0, then 10.1.2.0 and 10.1.3.0. And also R1 remote networks, we can see 10.1.1.0 and 192.168.1.0. The same way, other side on R2, we can see the connected networks, that is 192.168.1.0, that is N2, then 10.1.1.0 and 10.1.2.0. And for this R2 remote network, we can see 10.1.3.0 and this network 172.16.1.0. Now we are going to configure floating static route. Here we can see how we can communicate from PC1 to PC2. There are redundant paths. We can see the message can go from PC1 to R1, then it can go through R2 directly, then it can go to PC2. And also we got other way, that is from PC1 to R1, then it can go to RTR, then it can go to R2, and then it can go to PC2. So hence here we have a redundant path from this PC1 to PC2. Here whenever this our main path fails, that is the link between R1 and R2, the packet which should go through RTR. So here we need to configure the floating static route. So first of all, we will configure the this remote network for this router R1, that is network 3 and network 2. So we can use either recursive static route or we can configure static route using exit interface. Both concept we have seen in the previous videos. So here I am going to configure. So first of all, let me configure on R1. So we can see the remote networks, that is 10.1.0, 10.1.1.0, that is network 3, and 192.168.1.0, that is network 2. So first of all, we will configure network 2, enable configure terminal. So here we are going to configure IP route 192.168.1.0, then 255.255.255.0. Then here we will use exit interface. So we can see there are two ways to go to this network 2. Either we can go through this RTR or we can go through directly from R1 to R2. So the easiest way is from R1 to R2. So we are going to give the exit interface as serial 0/2/1. So whenever the packet comes from PC1, which is destined to this PC2, so it will forward to this interface serial 0/2/1, which is connected to R2. Then R2 will forward that packet to PC2. Right. So we are going to give the exit interface here serial 0/2/1, or even we can configure the IP address next hop address, the IP address of this interface serial 0/2/0. Also, we will configure the remote network 10.1.1.0 on R1. IP root 10.1.1.0. Then submit mask. Here also we will give the exit interface, and we will give a serial 0/2/1. So it will go through R1, R2, and then it will go to this network. Serial 0/2/1. We will just verify the configuration. Coming to R1, exit. So we will give a show IP root. Here we can see 3 connected network. So already we given that here. Let me give another command so that we can see separately those connected networks. Show IP root connected. So we can see those connected networks. Already we listed here. R1 connected network 172.16.1.0, then 10.1.2.0, 10.1.3.0. Also we configure the static root, so we can verify that using show IP root static, and we can see those remote networks we configured, that is 10.1.1.0 and 192.168.1.0. They are directly connected to serial 0/2/1. Next we will do it on R2, and here we given R2 is not aware of these two networks, that is 10.1.3.0 and 172.16.1.0. So we will configure that on R2. Enable configure terminal, we will give IP root. So first of all we will teach this network 1, that is 172.16.1.0, then submit mask. Then we can give like previously we given here, we can use either exit interface or we can give the next hop address. So we can see here also from PC2 to PC1 we got redundant path. It can go through either this way through RTR or directly from R2 to R1. So here we will give directly from R2, R1, then PC1. And we will use next hop IP address. So that next hop IP address is 10.1.2.2, or we can give exit interface also. Okay. So let me give here a next hop address 10.1.2.2. Okay. Also we will configure IP root for this network. 10.1.3.0. Then submit mask is here. The next hop address 10.1.2.2. So it will go through R1. We can verify it. Show IP root connected. So we can see those 3 connected networks. So we already listed here. Then just now we configured static root, show IP root static, and here we can see those static roots 10.1.3.0 and 172.16.1.0. Via we given the next hop IP address. Now we can see PC1 will be able to communicate to PC2, right? Still we did not configure the floating static root. We just only configured this static root using next hop and exit interface, right? And we can see R1 is aware of this network N2, R2 is aware of this remote network N1. Now PC1 will be able to communicate to PC2. We will test the connectivity. I will go to PC1 command prompt, and we will ping to 192.168.1.10, and we can see we get the replies, right? And we will see the path, how it those packets are moving through which devices. So let me go to the simulation, and I will give show all or none, and we will give keep only ICMP, so that we can see that packet traverse from one device to the other. So let me ping again, and we can see here one ICMP packet. It will go to S1, okay. It will go to R1, okay. In that packet, the destination is 192.168.1.0. It is already configured, and he will forward to the exit interface, that is serial 0/2/1, and that packet will go to R2. And R2 is aware of this network because 192.168.1.0 is a directly connected network for this R2. So he will forward that to the PC2. Right. Now he will give the acknowledgement back to this PC1. So he will forward that packet to the default gateway because this 1.0, 172.16.1.0 is a remote network. So he will forward to the default gateway, and this router is aware of this network N1 because we already configured static route using next hop address. So he will forward this packet to the next hop, that is serial 0/2/1. We given this IP address. It will forward to R1. Then R1 is aware of this PC1, same network. So he will forward it. So we can see our packet traverse through R1, R2, and to the PC. Okay, now what happens if we delete or this interface goes down? Will they communicate? No, they will not communicate because we did not configure this the other path. So we can check it. For example, I am going to delete this. Okay, let me delete this interface. Okay. Even just after deleting, if you go to the routing table, show IP route, and we cannot see that third connected network, that is 10.1.2.0, because we removed the connection between R1 and R2. So obviously it will not communicate. We can test it. We are going to ping to same PC2, and we can see packet is here. It will go to the default gateway because PC1 is not aware of this network. It's a remote network for PC1. So it will go to R1, and once it reaches R1, you can see that packet is dropped because the path is removed here. And when we given that show IP route command, we cannot see that static route to be configured here, right? So it is removed from the routing table. So when I give a show running config command, and when we come down, and we can see that IP route command is available in our RAM, but we cannot see that entry in the routing table because this connection is not available right now. Yes. So now we need floating static route. That means whenever our primary route goes down, so it will choose the floating route, whatever we give, right? So we are going to choose this route. So whenever this route goes down between R1 and R2, the packet should go through RTR. Then it will go to R2, then it will go to PC2, and the communication will succeed. So we need to configure floating static route for that. So we will do that next. We'll go back to real-time mode, and I will connect this connection between R1 and R2. Okay. Now we will see how to configure this floating static route. So we will do it on both routers R1 and R2. So here, suppose this route goes down, it should go through this way, right? So we are going to configure that. Okay. Here is the command IP route. So to this network, unknown network is 192.168.1.0. Then it 255.255.255.0, and then we can choose either exit interface or we can give the next hop address. This is the backup route, so it should go through this RTR. So if you are giving exit interface, you must give a serial 0/2/0. Let me give that serial 0/2/0. Okay. Otherwise, if you are giving next hop address, you must give the IP address of this interface serial 0/2/0 on this RTR. Okay. Now I am going to put a question mark here, and we can see we can put a distance metric for this route. Yes. So our primary route is through R1 and R2. If it goes down, it will choose the next route. We are going to give a distance AD for this administrative distance for this route. For example, we can give 5 or we can give 10. Okay. In the same way, I am going to give it for this remote network 3 10.1.1.0 also. IP route 10.1.1.0, then to mask, then exit interface serial 0/2/0. This is the backup route, and AD we will give 5. Okay, and we can see this entry, I mean this static route will not be added in the routing table. So just we will verify that. Exit, show IP route. So we can see only those two static route we given initially through serial 0/2/1 and serial 0/2/1. Now added two backup route. We can verify that using show running config, and here we can see those two backup route. So whenever this route goes down, so it will be activated. I mean this network, this route will be added in the routing table. Anyway, we will see that after configuring on R2 also. In the same way, we will configure on R2. We will configure the backup route to this network 1 through RTR. So we will do that. Configure terminal IP route. So remote network is 172.16.1.1, sorry 1.0 network address. Then subnet mask. Then we can give either exit interface or the next hop address. So it's a backup route through RTR. So let me give this next hop address, that is a 10.1.1.1, or you can give this exit interface. Okay, that depends on your wish. Then we are going to give the distance metric, we'll give 5. And also we will give this backup route for this network 5. Suppose this main link fails, it will go through this RTR. We will give IP route 10.1.3.0, then subnet mask. Then our next hop address we given 10.1.1.1 with AD 5. Now we can verify this. Show IP route. So we can see only two static routes what are we given initially through the main link between R2 and R1. But we also configured the backup route. We can see that using show running config. So here we can see that same route, we given the same route here, but through different way, through different path with the administrative distance. So whenever this path goes down, okay, this will be added. So whenever this link between R1 and R2 goes down, the packet will go through RTR. We already mentioned that. So we can see this RTR is also not aware of some of the networks like this network 1, network 2 and network 4. He is aware of only these two networks, that is network 3 and network 5. So we need to configure static route on this RTR also. At least we need to configure for this network 1 and network 2. So we will configure that also. Okay. So enable configure terminal. First of all, we will configure for this network IP route, that is 172.16.1.0, then to mask, then exit interface or the next hop address. So here I am going to use exit interface, that is serial 0/2/0. Okay, it should go through this way so that that packet will reach to this network. Then the other side, for this network N2, we will give IP route. We can see the IP address here, 192.168, network address 192.168.1.0, then to mask. Here also I am going to give the exit interface, that is serial 0/2/1. Okay, right. And here we are not going to configure for this IP route for this network 10.1.2.0. We can configure it, not a problem. Okay. Anyway, mainly we need to communicate from this network 1 to network 2. And if you want to communicate, you can configure static route. And here also we have a redundant path. If you want to communicate to this network, it can go through this R1 or it can go through this R2. So even we can configure a floating static route on this RTR also. Okay, perfect. Now we will test the connectivity. Again, let me go to simulation mode. So ICMP. I will ping from PC1 to PC2. Okay, so we can see this packet goes through R1, R2, then it goes to S2 and PC2, and acknowledgement back to R2, R1, then S1 and PC2. Shortest distance. Okay, it's successful. Now I will change it to real time and we are going to delete the link between R1 and R2. Previously we have seen static route is removed from the R1 and R2. Now what happens? Because we configured floating static route, and whenever we delete, that static route will be removed from the routing table, and it will add the floating static route we configured. It will add to the routing table on both R1 and R2. Just we will see that using the show command. Enable show IP route. Let me give a show IP route. And here we can see now. See that 10.1.1.0. Also we can see 192.168.1.0. But we can see it goes through the interface serial 0/2/0. Serial 0/2/0 because this interface is now down. We given the backup route, it will go through this interface. The same way we can see here in this router R2 also enable show IP route, and we can see those static route via 10.1.1.1. That is through this RTR. This is the next hop address we given for the backup route, correct? So even after removing this link between R1 and R2, PC1 will be able to communicate PC2 through RTR. Okay, we will test that. We'll go to simulation mode, and again we will ping to PC2, that is ping 192.168.1.10, and we will test the connectivity. It goes to S1, it goes to R1. Okay, so this network is, the destination is identified. So R1 will forward to the exit interface serial 0/2/0, which will go to RTR. Perfect. So RTR is aware of this network, that is 192.168.1.0 already we configured. So he will forward to R2. And R2 is aware of this network because it is a connected network for him. Right. Now PC2 will send back acknowledgement. So we can see it will go to S2, it goes to R2, and R2 will forward to RTR. This is the backup route to be given, and that entry is already in the routing table. So he forward to RTR, it goes to R1, then it goes to PC1, and we can see communication succeeded. Now, if I reconnect the link between R1 and R2, we can see the change again in the routing table. Okay, let me go to real time. So if I go to R1, and here we can see 192.168.1.0 is directly connected to serial 0/2/0. We can see that, right? Serial 0/2/0 through RTR. Now I am going to connect link between R1 and R2. It is connected. Okay. Now again we are going to our R1. So here we can see 192.168.1.0 going through serial 0/2/0. Now let me verify IP route. Show IP route. We can see the change. 192.168.1.0 now through serial 0/2/1, because now they removed the backup route because our main route is back. So this is the easiest way to reach to PC2. Correct? Perfect. So I expect you understood this floating static route, how it works. We can create with a lot of topologies. So this is the minimal devices and the connection we made in this topology. Now friends, if you get any doubt in this activity, you can contact us. All the details given in the description below. Also, if you wish to get any technical support, you can contact our team. So we will meet again in the next video. Thank you.